Hey everybody, back with some more GORF repair videos here. Jack Lick's Arcade Tech Repair Journey. Wow, I can't even believe I said all that. On my last video, I was doing some pattern board repairs, right? And I had a board, and I'll link to the video right here if you want to go back and watch it. Skip to the chapter that's relevant. But I had a board where basically the counter reset line on some of these pins, on some of these counters, these 4516 CMOS up-down counters, was high instead of being low. And basically I traced that back to U14, I think it was U14, and eventually I started cutting, pin 9, and I determined U33 was the problem. But I didn't have any 4516 counters. And so now I just got some 4516 counters in from DigiKey. Quick shout out to DigiKey. I only ordered probably like $40 worth of parts, and it came in this ginormous long box because I had ordered a bunch of ICs and sockets, and all the sockets came in like their own unique individual bag. Like I probably have $40 worth of packing material and stuff. I have no idea. But anyway, I just figured that was funny. Back to our normal program. So anyway, I got the 4516. I've already tested it, but I'm going to show you guys what it's doing now. It's, spoiler alert, it's not fixed. But I have this pattern board out, and I figured I'd power it on because the Symptom looks the same. If you have the pattern board out, it looks very similar to when I had the pattern board in and all of those counters were not counting with the reset line. You can see that the game is playing. It's changing different things. You can see some graphics being drawn. Obviously sprites aren't moving around 100% like they should, but you see some bullets coming. You see like the little explosion thing. So obviously those particular things aren't relying on the pattern board at all. Anyway, but that's the exact Symptom. I mean, it looks almost identical. So let me power this off. Put in our pattern board. So pattern board's in. Power it on. And now we have a totally different Symptom. It's better. And you can see this is where it's like doing the whole GORF thing. And then scrolling some crap, I mean, this is the intro page. But those graphics are completely jacked up. So new Symptom, same pattern board from my previous video. We're just going to watch it here real quick. I think go through the complete cycle here until it changes screens. Like here's some, I think the final of the text maybe. Let's see. Or maybe not. I don't know. Maybe it's stuck on this. Alright, here we go. Alright, so now we're getting something a little bit different. I mean, but look at it. It's totally jacked up. Alright, we got enough of the Symptom even though it can't focus. So the even better news is that while I was waiting on my DigiKey parts to come, and because I knew I had some other issues with another pattern board, I reached out to Sam's Arcade Fix on YouTube. I'll link to his channel and his video of using the reproduction Midway card rack test boards from Arcade Jason to diagnose some stuff in his GORF cage set. So Sam was super awesome and allowed me to borrow these. We actually don't live that close together, but we are in the same state. And he sent these to me, and that's super nice of him, and I can't thank him enough. And I really look forward to seeing what these are going to point out to me as being wrong with this pattern board that obviously I haven't completely fixed yet. So let me go ahead and set this up. Sam walks through how to set it up, and I actually am going to go watch his video so I can figure out how to set this darn thing up. So I'll be right back. Alright, I have Sam's board plugged in, and I watched one of his videos, but I'm pretty sure, and I also watched, I think, Classic Arcade, this little switch right here is determining which test ROM to use. So we wanted on the pattern test over here on the right, and the dip switches, I think the manual says that they aren't used, but I'm going to leave them exactly how Sam had it set up. And this slider switch should be in position 1. I actually don't know what it does yet. I'm going to look that up. And I have my video connector on J2 correctly. So if we power this up without a board on it, we should get a generic kind of all failed test pattern. And all we need in is the 2 RAM cards as well as the CPU board. So let's see. Cross your fingers. Not getting anything. That's not good news. Alright, I have my RAM boards in. See, I'm worried about messing up his board. That should work, right? I should get like everything failed. This is definitely the right for power and everything. It's the same connector and everything. Oh, I guess that J5 is actually to power it up if you wanted to, I guess, without the cage. I'm gonna have to research that. You could just run power right to that board. That's interesting. Does it just take a while? Not sure. Alright, just to make sure it wasn't my video connector, which works on my board, but I'm going to have to check the pin out, but I believe both pins, J2, 1 is ground, and then 2 and 3 should both be, I think, 12 volts. But I'm going to check that here. But before I do that, I hooked up just my composite video right there, and it's up, so I can see it with black and white. I don't know why it's not working through my RGB, so I will investigate that here in a second. But this is good news. I mean, I don't know what I did, but it was plugged in correctly. Plugged it back in. Boom, it's working. For some reason it was just a video connection, so much clearer. Fatal error, check, data latches, blah, 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 blah. Okay, so let's put on our pattern board. We have the pattern board in there. Pattern board in question with where we replaced that one counter. Ooh. It's not happy. Something bad. So it's so messed up that I can't even run this thing correctly. Yeah. Let's see if we reset it. Whoops. Man. Yeah, so pattern board. This is hard to get actually in there too, by the way. And I'm looking at how closely aligned the pins are. They're just slightly offset from the board, it looks like. I mean, they're on there, I think, but alright, I put in my board here. We'll hit reset. My working board. I just want to show you kind of what it's doing. Looks good, but it does go through some type of, you know, movement of data around on the screen from this thing. So all right, well, anyway, this board cannot even get past the thing, so the initial test, the thing. Oh, by the way, we live in the Commonwealth of Virginia. It's not the same state. It's the Commonwealth that both Sam and I live in. So, all right, be right back. All right, so I figured out next step is I'd put it back like it was and troubleshoot it while the game is actually running. I don't know if this is going to work. In my logic comparator, I put a 4516 TTL chip in there. and I was going to test some 4516s with it. So if I come here, alright, that looks bad, or at least, right? So, but then I came over to the one that I was just doing. Let me see here. And that looks good. And the game started working. I put my logic comparator on the chip that I just replaced, and my logic comparator, the load or something, I don't know what's going on, but why is it working now with my logic comparator on there? That is bizarre. Is this 4516 like too fast or something? I'm perplexed. It literally is working now by just having my logic comparator on. And now watch this. I'm just going to pull off the logic comparator with my hand. That's bizarre, right? All right, maybe I had a bad 4516. I just took the one that was in my comparator, threw it in there. Game's working. Or, oh, actually, there does look to be a little small glitch there. Yeah, there's some stuff still going on, it seems. Let's go ahead and put the test card back in and see what we get. Also, I'll test this in one of my programmers and see if it reports it as being bad. That's weird. I put the chip that I just had in there back in. I tested it in the my BK864 and it passed. And it's jacked up. I don't get it. So something is wrong with that chip and I don't know what it is. So I'm going to hold that off. Maybe one day I'll analyze it, but not today. It'd be interesting to kind of see what's wrong with it, but I'm going to move on. All right, here we go. Okay. Bad XY. X-wide. F0. Line, what the hell is that? Something... So it is giving us some clues that maybe bad X wide F0 and 2000 line ARCT bad. Boy, I'm gonna have to research that. This is pretty interesting. I've been testing different chips because part of X wide is U33, which is the chip that I just replaced, and I was having problems. So I started just like, let me try a whole bunch of these in here, and I get the bad, error there. And I bet I'm probably just going to shotgun these things, but I'm going to replace all of the chips in the X wide section. If you look at here in the X wide section, you have some 175s, and then you have 4 4516s, which all play a role here. And they are 4516s, right? Yeah. I don't know why only one output is used from each one of them. No, that's the reset. Let me look at that. I don't think the Q or whatever is used. It's only the carry out. And so 33 is carrying out to 40 is carrying out. So I'm going to replace all of them, I think. 42, 33, 40, and 31, because I bet they're just not, the older chips probably aren't working well with the newer chip or something. I don't know, that's my best guess, because I know these chips have got to be good. They can't all be bad like that. Alright, I'm back at this, and I have no idea what's going on. I replaced all the 4516s at U31. Let's see here, U31, U40, U42, U33, and if I remove, got my logic comparator on, looks fine, right? Remove it, totally messed up. And so I don't know what is the comparator doing with just another 4516 in there. Now granted, this is TTL, so it's definitely, you know, putting some load on the circuits, I'm sure. I don't know, I gotta probe around, I guess, but. Alright, back with the tester and my logic comparator on, so it actually completes. And it says bad linear counter. If I reset it, see, it's pretty consistent with this on U33. Take it off, reset, and it doesn't even like complete. And I'm wondering, so I have that on U33, and there's data input lines coming from U32. If I look over here, so data 4, 5, 6, and 7 come into U32, and that's like something 175. I think it's a 4175. So I'm going to look that up. I don't even know if I have any, but I'm going to probe those lines here real quick, because it only does this when I put the comparator on U33, and I don't know if it's doing something with the data input lines there, because so my only hunch right now. Obviously I could look at the linear counter area as well, but why, this just has to be something here. Alright, I think I'm going to spare you a whole bunch of stuff, but I went ahead and socketed U33 again. Actually, this is the second time I socketed, and same chip, got issues, right? Alright, so let me pull that chip out. Off camera probably. Alright, and replace that chip. And it's working, but we do have a little bit of some graphic issues here. So, and I think that's why the linear counter or whatever is jacked up. You see some issues there, but we're going to be able to move on from this freaking craziness. I was even testing it without, I was just like using the logic probe to put some load on the chip, and it would clear up this chip right here. I'm going to test it in my tester here in a second, but I don't know what. So bizarre. And you can see some lines, you know, kind of, those would be, I don't know, are they horizontal lines or what's going on there? Vertical, right? As the things move to the side. Alright, so let's put back on the test board. Alright, I was testing it at some 4516s in here, and sure enough, the one I pulled is bad, and it's a brand new chip. See? Tested bad, even though it must have been a timing thing. I have no idea. So crazy. And binary counters, I would have had to have probably used a logic analyzer to figure that out, I think. So that thing is bad. Chuck it in the trash. This is crazy a little bit. Alright, so I'll reset it. And it says we have bad X wide and bad linear counter up there. Right? See, bad X wide right there. F0, whatever the hell that is. I might figure it out here in a second. But let me go ahead and... Alright, so I have nothing on. I'm just using it as a logic, and you know, not a logic analyzer, but activity meter or whatever. Hit reset. Now my X wide's okay. That is at U31. Hit it again. X wide's okay. What is, I don't know, did I get some bad chips or something? So crazy. I wonder if I can do the same thing over here and see which one of these is bad. I mean, that's just weird. I have a little bit of a load on there. See, that X wide, F0. Alright, I'm going to do some research, but there's literally no chip in here. It's just putting, you know, a little bit of load on the chip, and for some reason it clears it up when I had it on U31. Now, U31 is one of the new chips I had. So maybe that one's slightly bad as well. Not sure. Alright, so with nothing connected, obviously, my little crazy inductance or resistance thing there, you got bad X wide F0. F0 in hex is, look here, F0 in hex is the binary data 0, 1, 2, 3, data line 4, 5, 6, and 7. And if you look here on the schematic in the X wide section, data line 4, 5, 6, and 7 is U31, as well as U33 and U32. And I just replaced U33, so I don't think it's that. And meanwhile, when I do my little dumb test here and put this on U31, hit reset, it passes the test. Now, I don't really get it, but I'm going to replace U31 and see if we get past at least the X wide issue there. Alright, I'm trying to get real creative. I'm not going to show you everything, but I actually hooked up my FPGA cat box with the Z80 adapter, just the CPU board and the pattern board and the RAM boards, but I probably don't even need the RAM boards. And I was going to use, let's see here if you can see this, okay, come to signature analysis. Basically, I was using the data counter, the address counter and data counter, and enable read write, so that basically I could get signatures on the data bus and see if I could get the counters to count in a consistent manner, because I'm running, you know, the basically like not a no operational but a sequential bit pattern on the data bus as well as on the address bus, but it wasn't working. But I just figured I would mention that I was trying to get creative and try to see if I could get something that was repetitive and maybe do signature analysis on the pattern board, which would be cool, but it's going to be a little bit more work than I'm willing to do. One thing though, just for my own documentation, is pin 28 is the watchdog, and I grounded that, and that prevented the board from constantly being in reset. So that's what you see there with that little jumper right there, just ground pin 28. And let's see if I wanted to say anything else. I would show you, but honestly there's nothing to show. I get good, you know, data signatures, but I can't get the counters to count. And there's so much other stuff, like I might have to write stuff to, you know, the port addresses, who knows, I don't know. I would have to really, you know, go deep, and I've already wasted like a good weekend screwing with this. So let me see what else, if I'm going to do something else here in this video. Alright, so I'm going to move on from this board here, this board with the F on it, which I think was board number 1 in my last video. Yeah, I went back and labeled them all so I could keep track. I can't figure out what's wrong with this, and I need a logic analyzer, I think. Otherwise, I'm just going to be guessing around and stuff. So let me try this one. This is board number 4 that I think had the jumpy graphics. Yeah, you can see that they're kind of like bouncing around, and it's smushed up at the top there. And I think that's the only issue with it. So let's go ahead and put it on Sam's Arcade Jason replica there, and we'll see what the errors are and if we can figure something out with this one. Alright, have it hooked up. Let's hit reset. Bad area load. Bad area load is the error there. So let me look at the schematic, refresh my memory on where that's at. Okay, just trying to get a clue. It says bad area load 0009. And if I come to the schematic here, that is, if we're just looking at the data, so I don't know why it has 4 hexes instead of 2, but 009, where's my calculator at? Oh, I closed it out. Nine in hex is 1001, which is data 0, data bit 0, 1, 2, 3, which should be U39 as an example. And the area load is U30, 39, 36, and 27, which 2 are LS, not LS, 4175s or 4516, those binary counters. Anyway, I should be able to check the 175s, the flip-flops, with my oscilloscope with all 4 channels. That's enough to kind of see what's going on there. Okay, doing some experimentation just to see how well this is going to put me on the right track. So D0 comes into pin 4, and then it's a flip-flop, so it's goes out pin 2, and then the opposite is on pin 3. D1 in on pin 5, out 6 and 7. And I think we're only using like the set pin 7, pin 4 for the outputs, pin 10, pin 15. So if I ground one of the outputs, like we know, or based off of the 9, I think it was 1001, so we know that this one's bad. So if I ground pin 7 on U39, we should get a change in our hex readout here. Let's see. It says B, and B in hex one, data bit 0, data bit 1, 0, 1. So with that 9, we know that 2 of the data lines, data bit 0 and 1, are not working correctly. Let me show you another thing here real quick. Sorry for the moving around there. We'll move it up to U30 pin 7, because they're basically symmetric to each other. 4 data lines. There should be data line 5, I think. And now we get the bad area load 29. And 29 in hex is 1001. That's our 9. And then 01, which is data line 5. Data line 4, 5, 6, 7. Yeah. So yeah, the test card is definitely giving us clues. Now I just need to figure out if it's actually that chip or not. I mean the U39 chip. Alright, I know I'm repeating myself, but I have my oscilloscope. Clock is channel 1, that's on pin 9. Then I have my input channel 2 on pin 4, and then my outputs channel 3 is on pin 2, and not Q is on channel 4. So I'm just testing data bit 0 right now. And the one issue when you have this board is it's not constantly running because it stopped, right? The test mode is stopped. I don't know if that's a good thing or a bad thing, actually. So I am triggering on channel 1 clock. Channel 1 clock on the positive edge trigger, and then I'm just going to hit reset on the board. And basically, clock went high, data input is 0, and my no change in basically my outputs. So let me change this to trigger on channel 2, which is the data line. Let's do single, reset. Oh crap, hold on. Alright, let's change that to channel 3 on one of the outputs. Single shot, reset. Oh, it did channel 4. I meant to do channel 3. There we go. Single shot. Okay. So data line went high. Clock went high. Data line's high. Therefore, my output went high, and not Q went low. So that, I think that looks correct. Obviously there's a little bit of noise on the data line. I don't know. It's not a perfect, square wave all the time. There's a little bit of noise there, as you can see, but I don't know. How else am I going to test this thing? It looks somewhat good, unless it's only failing every once in a while, and I can only do a single shot when I'm doing this reset. I don't know if I can actually record. Can I go backwards and forwards? I have no idea. Maybe I can hit run, hit reset, and then hit stop. And can I do anything here? Can I go back in time? No. That's my trigger. I have no idea. Alright, just showing that I did it for data line 3, which is pins 15, 14, and 13. And it still looks good when I'm triggering on the data output pin 15, basically channel 3. So I don't know, it's got to be somewhere further down the line. I would think that this flip-flop is good, and maybe it's the counter, I'm not sure. Right, it's interesting that it says U39 or U36, I think, right? Or U30 or U27, because this is the area load. But U39 feeds U38, which is in the feedback section. So it's like data here, goes to the binary counter, which goes to another flip-flop, which feeds back into U38. So there's like a loop here, and U36 is in between. Anyway, I piggybacked U36 with a 4516 counter. And if I get it to reset here, it says it looks good. I just did a piggyback U36, so doesn't mean 100% that it's right, but I'm going to go ahead and replace U36 and see if we fix it. Alright, just before I replace it, and I have the soldering iron on, so I figured I would just look at the outputs here. But again, it's kind of hard when you're running this test because it goes so fast. So what I did is I hooked up channel 1, and I'm just running single shot on the outputs, single trigger basically. And if I come to pin 2, which is one of the outputs on the 4516, alright, and then I'm gonna hit all this camera movement, sorry about that. I'm gonna hit reset, and I get no trigger, right? See that? Pin 2 doesn't do anything. And if I come to like pin 6 or pin 7, I still have it running on single. Hit the reset switch, and I do get a little up down, which seems a little weird actually. compared to the other one. That's pin 6. Pin 7. Hit our single shot. Hit reset. Boom. You see how it goes high and it stays high for a while? I don't know if that's normal for pin 6 or not. Let me, another counter is U. Let's see what this one looks like. U27. Yeah, pin 6. So pin 6 and pin 2 look bad on U38. U36. So yeah, I'll check pin 2. I don't know what these counters are supposed to be doing, but comparing and contrasting it with this, let's hit single. Yep, that's pin 2 on the other one. All right, that's making me believe that this is jacked up. This U36. Okay, replaced U36. Let's see what we get. Looks good. Awesome. That's an interesting thing. I made progress, and because this board was a little bit easier to fix, in my next video maybe I'll come back and assemble my own test boards that I got from Arcade Jason and go back to board number 1. But let's go ahead and put this fully back together and just look at it in the game. Right. Board number 4 back in. Uh-oh. There we go. Little reset. Much better. Our mission, it's not collapsed up there. Oh, is something else going on here? What's going? I don't know what's going on with my board set here. All right. It's definitely not the pattern board, because that looks normal. I'm worried about like using my cage and just inserting and removing a whole bunch of cards all the time. It's probably not ideal. But there is somebody who makes reproduction bottom boards or whatever, the card cage. So that looks good. We'll just watch it all the way through, make sure there's no other glitches. Yep, looks good. So I still got board number 1 is the bitch of the bunch. This one right here, board number 1. But I'll come back to that. So definitely a learning experience here. That's it, everybody. Cheers till next video.